Okay, chapter 7, right triangles and trigonometry. 7.1 is all review with using the Pythagorean theorem. So starting with the basics, Pythagorean theorem, it only works for right triangles, and the C side is always the longest side. Here's our picture. A and B are your legs, C side is your hypotenuse. Your hypotenuse is always directly across from your 90-degree angle. And this is the formula for the Pythagorean theorem. A squared plus B squared equals C squared. So again, the A and the B side are the legs. The C side is your hypotenuse, which is always your longer side. So let's look at some examples here. A basic example here, it says find the unknown side length, round your answer to the 10th place and simplest radical form. So this is a really basic problem. Notice that our legs, 6 and 5 are the legs, the hypotenuse is your x value. So when I plug this into the Pythagorean theorem, 6 squared plus 5 squared equals x squared. I'm talking super quick, so if you'd like to pause this or rewatch it, you can always do that. Squaring 6, squaring 5, that gives me this. When I add 36 and 25 together, that gives me 61. Then my next step, I'm gonna square root both sides. Square rooting and squaring cancel each other out to give me my x. On my left, when I square root 61 on my calculator, I get 5.8. Notice the directions did ask me to round to the 10th place. So this is my rounded answer. My simplest radical answer, I want to look for the number in simplest radical form, meaning there's no perfect square factor under that radical. A perfect square factor would be 4, 9, 16, 25, 36, or anything bigger following that same pattern. So you're multiplying the same number together to get these perfect square factors. None of these numbers go into 61 evenly, so I can say that the square root of 61 is simplest radical form. And I will explain that one a little bit better in the coming lessons. Next example talks about the area of a triangle. This should be familiar to you. 1/2 times the base times the height. Remember, the height has to be perpendicular to the base. So if we're finding the total area of this whole figure, we kind of have to pull it apart, and there's more than one way to do it. What I did is taking this triangle, this is this big part of the triangle, the base is 13, the height, which is perpendicular, is 4. When I plug that into my formula, 1/2 times the base times the height, that area is 26. And then over here is the other part of my triangle. My base is 3, my height is 4. So this triangle has a base of 3, a height of 4. Plugging it into my formula, 1/2 times the base times the height gives me an area of 6. Putting those two areas together, the complete area of the whole figure is 32 inches squared. Please make sure that if inches is given to you in the original problem, that you put inches squared in your answer. Of course, area is always units squared. Pythagorean triples, it's 3 integers that satisfies this formula. Satisfied means it works, and that equal sign is there for a reason. So this means when I take A and square it, and I add it to B squared, it's gonna be the same as when I square C. So if it works, it's a Pythagorean triple, and we can't have decimals in this situation. So here's some common ones that you'll run into quite a bit. There's also a bigger list in your book. I don't want you to answer, I don't want you to memorize these, just be familiar with them. So we're gonna use this idea to find an unknown side. So these directions are rather long. What it basically says is we're giving you two sides of a triangle. We know that it's a Pythagorean triple, which means there's no decimals. And we have to figure out what the third side is and what side it is. Is it a leg or is it a hypotenuse? So looking at my first example, so we have two scenarios. We have 40 and 41. It could look like this, where we have 40 here, 41 here, and this is the side that we don't know. Or it could be this scenario where 41 is my hypotenuse and the other side is a leg. We have to figure out which scenario works so that we can find an answer that doesn't have a decimal. I started with this scenario. I put in 40 and 41 into the Pythagorean theorem, and I want to see if it works, meaning I get a whole number. So when I square my numbers, these are the numbers that I get. When I add them together, I get 3,281. When I square root both sides to solve for C, I get a decimal. This tells me right away that this scenario does not work. So look at the difference on how I did this problem and how I did this problem. The biggest number is always your C side. So I put 41 for my C and 40 as a leg. So I'm solving for an unknown leg. Similar kind of situation where you're going to solve it. Square it. I subtracted 1,600 and put it over here. That gives me 81. square root both sides, and I get 9. Because this is a whole number, I know this scenario works. So my 3 sides of my triangle is 9, 40, and 41. Because it's a B, we know that it's a leg. So this is the unknown side, and I'm identifying it as a leg. It's not the hypotenuse. If this scenario had worked, it would be a hypotenuse. In this scenario, it's a leg. Let's look at one more example. I'm given 28 and 45. I have to find the unknown side and identify it as a leg or a hypotenuse. I'm going to plug this in as 2 legs first. Again, this is what I'm starting with. You can start whichever way you would like. So these are my 2 legs. I'm going to see if when I plug it in, if I get a whole number, then it would be our hypotenuse. So I squared this number, added them together. At this point, I'm going to square root both sides. When I square root both sides, I get a whole number, which means this scenario works. So because it's C, the C side is our hypotenuse. So my full answer would be 53 is the unknown side, and it's a hypotenuse. If this scenario didn't work, and it does, I would have to go to my next step, which would be 28 squared plus b squared equals 45 squared. I don't need to do that because I got a whole number in this scenario. So if you need to rewind and look at this again, that's fine. These are a little bit tricky, but they're very doable. Here's your homework. Remember, you will have a quiz on 7-1 next time. Make sure you're staying on top of homework and studying.